Greetings and welcome. Today, we're talking about analyzing graphs of quadratic functions. Now, you guys know how to graph a quadratic, right? You're able to, like, here, I'll do a little recall for you. How about recall, real quick? You guys know y equals ax squared plus bx plus c, right? You know that that's going to be the graph of a parabola. You know how to find the vertex, right? That h is equal to negative b over 2a. That k is going to equal f of h, right, where you just plug in that x coordinate. You could find the roots or the x-intercepts, right, by setting the function equal to 0 and solving. You can find the y-intercept, right? You know all this stuff. You guys you're so smart. I'm so impressed. I love it. I'm so proud of you guys. So you know all that stuff. But what if I told you there was another way, another form of quadratics that was somewhat helpful? Right, because recall that in all of these cases, it's not like I could just instantly look at this and know what the vertex was. I had to like do formulas and calculations to get it, right? Also, oh, you guys also knew all stuff about A, right? That you were able to like, you know, factor and blah, blah, or know which way it opened and blah, blah, blah. Well, let me show you this. It turns out there's something called vertex form. What? Vertex form, you say? Yes, vertex form of the equation of a parabola. So, vertex form looks like this. Y equals a parentheses x minus h squared plus k.
What does that mean, right?
Well, it represents the equation of a quadratic. It just has this nice square of a binomial on the inside. But based off of this, what would you suspect this tells us? What facts do you think are true about it? What do you think that h and k represent? The vertex, hence the name, vertex form. So the vertex is actually going to be positive h comma k. Isn't that nice? And then a is the same a that we'd seen before. So you can tell me if a is positive, actually let me specify it this way. I could tell what way it opens, where if a is positive, it opens up. If a is negative, it opens down, right? All classic sort of things. And you can also tell whether it's the shape of it, right? The stretch or smoosh, right? So if the absolute value of a is greater than 1, you know it's a stretch vertically. Stretch, there we go. And if the absolute value of a is less than 1, you know it's a smoosh vertically, or a horizontal stretch, depending on how you want to call that. And you can also find the slopes of the parabola starting at the vertex, where it's going to be the up 1 over 1, up 3 over 1, up 5 over 1 thing, except where we have to take those. Where's my mouse at? Guys, this is weird. My mouse. There it is. Huh. Okay, I'm back. Whatever. I can multiply the numerators by a in order to get the new rises, right, for those slopes. So all sorts of cool stuff. So this is actually a really helpful mode to have. So let's do a problem. Let me give you one. Example. Let's graph and find the vertex, axis, symmetry. Is there anything else I'd want you to find? That's fine. That's fine. Whatever. So let's say I have f of x equals, let's do 2x, no, 2 parentheses, x minus 1 squared minus, let's say 4. Bam. Okay? So looking at this, could you tell me what a, h, and k are?
A is 2.
Yeah?
H negative.
Wow.
No.
Notice that it's x minus
Oh,
h.
1.
So it's going to be the opposite of that guy, which is a classic right there. Okay. Yep.
And then k is -4.
Right. So k does keep the sign there. All right. So what does that tell us? Well, we can gather information. Let's see. That means the vertex is the point 1, -4. Which way does this open? Opens up because a is positive. Plus, 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 right? And it's a stretch by a factor of 2, right? So then I could even find some slopes if I wanted. So it'd be 2 times 1 over 1, 2 times 3 over 1, and 2 times 5 over 1. Right, so that's just going to be 2 over 1, 6 over 1, and 10 over 1, right? Okay, so let's actually give this a graph. Oh, you know what? I'm going to open up Geometria Sketchpad. Actually, Sketchpad, I wonder if I could use the word Quaderno for Sketchpad. What do you guys think? Maybe. Yeah, so Geometria Quaderno. Do you think Sketchpad and Notebook are close enough in concept? I would say so. Sorry, wait, I'll be right back. So let's see. My vertex is over 1, down 4. It opens up with a stretch of 2. So I'm going to reposition this. Let's see, down 4, huh? That sounds good to me. Somewhere like that. And you guys have graphed these before. It's going to be the same O sort of thing. So the vertex is at over 1, down 4, right? Now, question. Oh, what is the what's the y-intercept for this? Yeah, it's actually a trick question.
X.
Trick question. We don't know the y-intercept. A lot of people would be tempted to say it's -4. However, when I expand this out, okay, I'm gonna get 1 squared and get 1, and then I'm gonna distribute 2 into that and get 2. I'd have to combine that to find my new c term. So I don't know the value of c, so I don't know the value of the y-intercept off the bat. Okay, I just want to point that out. We'll do some analysis of that in a second. So let's see. I know it opens up. I know it's a stretch. The slopes are up 2 over 1. Right. So up 2 over 1, up 6 over 1, up 10, all the way up to 14 over 1, right? So that was 2, 6, 10, right? So those are some points that I can use. Bless you. Now question, what is the axis of symmetry? I didn't find that. Does anyone remember how to find the...
Midpoint.
It's going to be x equals, so it's always the equation of a vertical line. What number? The 1, yeah, it's going to be the 1 there. So if I want to graph the axis of symmetry here, that's just going to be this guy. Close enough. So I can actually then find more points than just those by mirroring. Wah, wah, wah. And yeah, that would be right there. And then I can draw my prettiest parabola. Man, seriously, that sounds like an awesome 80s toy for girls. I'd be a millionaire. I'll have to time travel.
So the x-intercept, the y-intercept is -2.
So it appears as though the y-intercept is -2. And there's a graph. I don't know where the x-intercepts are, but in this case, they weren't necessarily important to being able to graph it, because the vertex is the most important point of any parabola. So the fact that I was able to just look at this equation and is like, bam, vertex, no calculations other than oppositing that thing, right? That's an awesome thing to be able to do, right? That's pretty great. It's a good feeling. So I could find the x-intercepts. Actually, how could I find the x-intercepts?
Count the same distance away.
Yeah, I'm going to call this bonus. Let's do 2 things. Let's find the x-intercepts. You don't have to do this at all tonight, okay? Find the x-intercepts. What did I do back in the day to find the x-intercepts? Or the roots? I set the function equal to 0. So let's see what happens if I set this. Ah, that's not the copy tool. Bam, there it is. Set that equal to 0. All right, so there's my function. Set that equal to 0. And watch, to solve this, why don't I just do this old? Oh, what? No, I didn't. I mean, it's in such a nice format, it's almost like it's a partly done complete the square problem that I could actually do this, right? X minus 2 all 1 all squared equals 2, and then what would I do to both sides? Root, plus or minus, don't forget it. Yeah, so it's going to be irrational, but that's fine. Plus or minus square root of 2. I'm not going to, take you out in the ocean, tie some heavy things to you, and throw you in over believing in the square root of 2. Seriously. Why would I do that, guys? So yeah, I do happen to have 2 irrational x-intercepts, which is fine. But I just want to point out you could still find them, and solving this was actually kind of cool because it was already in this form if I was interested in that. And 1 plus the square root of 2. Square root of 2 is about 1.414. So 1 plus 1.414 is going to be 2.414. Yeah, so technically it should have been more right there. And 1 minus that would be negative 0.414-ish, right? So somewhere like that. So yeah, I could find the exact values of that as well. Now, what about, I'm going to just try to fit it right here since I managed to. What if I wanted to find the y-intercept? Let's see, and the first point I want to point out is that y-intercept is not necessarily equal to k, okay? So that's the first thing that I want to point out. So let me take this equation. Man, why do you guys take so long to write? I can just like copy paste things so quick. You have to rewrite things. You have to make your own grids. It's a shame. It's a shame. So let's see. So this was equal to y or whatever, right? Y equals this. I'll reposition it. Tell you what. Bam. It'll make me happier. So y equals this. So if I want to find the y-intercept, I just want to point out it is almost never going to be that number. It could, on occasion, if this was a 0, all right? Then it would end up being that number. But most of the time, it will not, okay? So let's actually expand this out to figure this out. X minus 1 all squared is going to be x squared minus 2x plus 1 if I was to FOIL that or use a pattern. Then I could do some distributing. Man, it's been a while since I've done some good classic distributing. Let's see, so y equals 2x squared minus 4x plus 2 minus 4. And then I'd be like, hey, let's combine some like terms, friends. Ba-bam, ba-bam, right there. And I'd get y equals 2x squared minus 4x. What's that? 2 and negative 4 combined to be negative 2, did you say? Negative 2, did you say? Negative 2, did you say? Yes. Wow, isn't that awesome? It lined up. It worked. So my y-intercept would be 0, negative 2, taking that from there. Not bad at all. And notice also analyzing this, I just want to point out the value of a is still the same. The value of b, I could actually do the, ax squared plus bx plus c stuff. I could find the vertex using this again. And if I do negative b over 2a, do you know what I'm going to get? I'm going to get 1 and negative 4. Guaranteed. Guaranteed. So I just want to point out it's a really cool form, right? So what about, if vertex form's so great, what if a problem's not given to me in vertex form, Jacob? Wouldn't that be wonderful if I could show you a technique and how to write it into? Yeah, what if I asked us to write the equation in vertex form? Mm-hmm. So like remember back in the day, maybe when you guys were working with slope-intercept form of the equation of a line, not all the time they gave it to you in that form, but you know how to like manipulate it, solve for y, so that you could get that form. That's what we're going to do right now. What if I have this? Y equals negative x squared plus 24x minus 60. So here, this is in standard form. You guys could tell me the y-intercept. You could tell me the value of a, that this opens down and is a regular shape. But I want this in vertex form.
You have to find h and k to do that.
Well, I guess you could really, yeah, you could find h and k and then rewrite it your own way. But I'm going to actually have us transform this into vertex form. So here's vertex form that I'm shooting for, right? So notice, when have we had this show up before? I mean, it's kind of like if I called this, I don't know, like a minus b squared, right? That's a pattern. And that pattern, we were solving quadratics a while ago where we would fast factor things into that form, remember?
Yeah, the a squared.
Yeah, a squared minus 2ab plus b squared, things like that. So that can show up. I can manipulate this into giving me that if I complete the square. So watch this. This is going to be really interesting. The first thing I'm going to do, all right, is factor out the a from this. All right, so I'm going to steal not the GCF from the first two terms, just the value of a. Okay, so I'm going to have y equals negative 1 parentheses x squared minus 24x blank minus 60 blank. And what I'm going to do, if I can complete the square on this, I could then fast factor it into that form. Okay? So how would I complete the square? How do I find my new c term? Does anyone remember the formula?
Negative 24 divided by 2.
Oh, it's not negative b, it's b over 2 all squared, right? So, yeah, negative 24, as you just said, for my new c term, negative 24 divided by 2 all squared. It's going to be negative 12 squared. It's going to be 144. So I can add 144 in the world of parentheses. But be careful, friends. Adding 144 in the world of parentheses was really subtracting 144. And now I want to point out one other thing before I do anything else. Notice where my equal sign is. I have both of my lines on the same side of the equal sign. So to balance this out, I don't want to do the same thing. I want to do opposite things, right? Well, so because this is really subtracting 144 on this side, I could have subtracted 144 on this side, but that's the same as doing what over here? Adding it. All right, so this is kind of weird. But I want to do the opposite of what I did because I want to keep the y by itself. I don't want to add 144 with the y. Y needs to stay by itself. And sometimes that won't even be a y. That might be written as f of x or g of x or whatever. So this over here, let's see, what's that going to be? That's going to be minus a times b, if I really wanted to write a formula about that, or a times nu c. I'll write nu c. Will that always work? Yeah. So minus a times nu c is that number there if you want to have a formula for it, but I find it cooler to just figure it out. So let's see, y equals negative 1. What is this fast factor to become? X minus 12, right? I can just steal that number right there. So all of our completing the square skills are coming back. And negative 60 plus 144, I believe that's positive 84. So look, I was actually able to manipulate that and put it into vertex form. And then from that, you guys could tell me that the vertex was 12, 84, the value of a is negative 1, and all of that information there. So it required this kind of complete the square, all right? So the idea was complete the square. To put it in vertex form. Right? So that's the idea of what we ended up doing here. So let me try, let's see, we're only on 19 minutes for this video, so I'm happy. I'm happy with that because this concept's a little bit meh. Takes a little bit of tricks on it. Let me do one more problem, kind of like that, just where it's maybe a different number out front. I might not even take it the whole, we'll see. So same directions. Let's say I want to do this. Yeah, let's do rewrite in vertex form. If I have f of x equals negative 5x squared plus 80x minus 319. So I want this in vertex form. What is vertex form? You guys have it all memorized right now. Y equals a parentheses x minus h squared plus k. Remember, it's the opposite of the h there. So I'll factor out the a, negative 5 here. So I'll get f of x equals negative 5 parentheses x squared times what? Negative 5 times what is 80? 16. 10 times what is 80 would be 8. 5 times double that would be 80. Yeah, that makes sense. So negative 16x. I'll throw a blank in there, foreshadowing what I'm going to be doing. And minus 319 blank. Okay. All right. So now I want to complete the square. So positive 64 here, right? Now, adding 64 in the world of parentheses was really subtracting, what's that? Subtracting 320. 5 times that. Okay? So I just subtracted 320 from this side. So to counteract it, I have to add 320 on this side because I'm on the same side of the equal sign. That's why I'm doing the opposite of that. Okay? And once again, this value you can get by doing a times your new c. Right. So let's simplify this. F of x equals negative 5 parentheses. What's that fast factor become? X and this minus 8. You can, bam, get right from there. And yes, plus 1. And you guys could tell me that the vertex was what? If I asked, what is the vertex?
So to get that 320, you did 5 times 64? Or negative?
Yeah, negative 5 times 64. Yep, is where that 320 came from. And I did the opposite of that. So that would have been minus 320, so that's why I added 320. Yep. So what's the vertex here? Positive 8, 1. Remember, it's the opposite of that guy. Actually, I even want to make a note. It's just for that one. Opposite. And then you guys can tell me that the axis of symmetry is, right, x equals 8. It's the equation, not just the number. You could tell me that this opens down because that's negative. You could tell me, is this a stretch or a smoosh? 5 is, the absolute value of negative 5 is 5, which is bigger than 1, so it's a stretch vertically. And you could find the slopes, right? So the slopes would have been 1 over 1, 3 over 1, and 5 over 1, but I'd multiply all of those by negative 5.
So negative 5 over 1, negative 15.
Precisely. Right, and then you guys would graph this because you're all awesome. Oh, 15. Right, so I just want to point out, this is actually a really cool form to know. I think it's super easy. It's probably easier than the other way to do things because to find the vertex is the most important point of a parabola, right? That's going to answer all your questions of like, what is the maximum profit you can get in this situation? What is the highest that this angry bird flies? Right, all sorts of things like that. Good stuff, good stuff. Yep. So thanks for watching, Internet friends. Have a great day. Bye-bye.